Good afternoon, students. So, in the previous classroom discussion topic, we had a discussion on the hardwired control signal generation method. Now, today we would like to discuss about the CISC type of processors. Okay. So now I would like to share my screen. So this CISC style processors. This lecture objectives are: this session will develop the students' knowledge on instruction execution using CISC style processors. So, how we can execute the instructions and how the CISC style processors are different from RISC style processors, and the instruction execution, how it will be different. That we will see in this today's classroom discussion topic. So, we already familiar about this RISC style processors. So where all instructions can be executed in a uniform manner, whatever it may be, whether it is a load instruction, store instruction, or any arithmetic logic instruction, it always follows the 5-stage hardware for execution of the instruction. So as a result of that, we are getting the hardware which is simple and well suited to pipelined execution of the instructions. And also the control signals are easy to generate because we are following a, a same 5-stage hardware for execution of any type of instruction in the RISC style processors. So the CISC style instruction set is more complex because they allow much greater flexibility in accessing the instruction operands. So unlike RISC style instruction set, where only load and store instructions are used for accessing of the data in the memory, whereas these CISC instructions can operate directly on memory operands. Also, they are not restricted to one word in length, the instructions, because in RISC style processors, every instruction will occupy one word in length. So an instruction may use several words to specify operand addresses and the actions to be performed in the CISC style of processors. So therefore, the CISC style instructions require a different organization of the processor hardware comparing with the RISC style processors. Now you will see this CISC style processor organization. So here we have a register file as usual, which we have seen in the RISC style processors. So these registers, we have the outputs A and B will be there. That outputs will be given as input for interconnector. Okay. So this is again here we have a processor memory interface is there. So this processor memory interface through which you can connect to cache and main memory. And here we are taking a temporary registers we are taking here, because these temporary registers will provide the service as similar to this interstage registers which we have used in RISC style processors. Okay, we have used interstage registers in RISC data path while we are executing the instructions. So that interstage registers are not available in the CISC style processors. So in place of that, we are making use of these temporary registers. Then we have this IR register and PC register. So the instruction address generator is another important component which will be used for generating of the uh, address of the next instruction to be executed. That will be loaded into the PC, and then the control circuitry will be there, so which will be used by this IR once the instruction is loaded into the IR. So to generate the control signals, this control circuitry will be used based on whether read or write operations we are doing onto this memory. And then here we have the ALU. So as usual, we are going to get in A and in B are the two inputs for ALU, and out is an output, and that output will be again directed to this interconnect. Now this interconnect is responsible for storing of that output either into the register file or into the memory address. Fine. So this is the simplest organization of these CISC style processors. Now the important point here is that how this interconnect component is implemented in the CISC style processors. Okay, so the main difference between this organization, that is the CISC style processor organization, and the 5-stage organization which we have discussed for RISC style processors, is that interconnect block which we have used in the CISC style processors. So what this interconnect block will does, it will provides the interconnections among other blocks and does not prescribe any particular structure or pattern of data flow. So it provides paths that make it possible to transfer data between any two components as needed to implement instructions. That is the responsibility of the interconnect. So the multi-stage structure of RISC style processor data path uses interstage registers such as RA, RB, RZ, RY, etc. So these are not needed in the CISC style organization. So instead of that, some registers are needed to hold intermediate results during instruction execution. So the temporary registers block in the previous figure is provided for this particular purpose, and this temporary register block will have two temporary registers, temp1 and temp2. So now this is the point for a reflection. So what are the differences between CISC style processor from RISC style processors? So just now we have seen that few differences we have seen that. Okay, so RISC style processors will always use load and store instructions for memory accesses. No such instructions are present in the CISC style. And RISC style instructions always use one word length, whereas the CISC style processors may use the instructions more than one word also. Okay, so to specify the operands. Fine. So now in order to implement this interconnect, so the interconnect block is nothing but how it is implemented in a CISC processor. So in that we are making use of this the 3-bus implementation. So this is a bus A, and this is a bus B, and this is a bus C. So we are using a multi-bus architecture, which we are calling it as a 3-bus architecture here for implementation of the CISC processor. So the interconnect in the CISC processor may be implemented using one or more buses. Fine. So here in this particular diagram, and all registers are assumed to be edge triggered. So that means in the during the clock pulse edge triggering, the data will move from one registers to the another registers. Okay, so that is done through via different buses. So addresses for the 3 ports of the register file are provided by the control block. So the control block is responsible for providing that this A, B, C, which we are giving it as the 3 ports for this particular register file. Okay, so then these connections are not shown in to keep this figure simple here, uh, and also this immediate block through which the IR is connected to bus B. Okay, so IR instruction register is connected to bus B via this control block. Okay, and this ALU is taking the input from one input from bus A and another input from bus B. It is taking and performing the ALU operation and generating the output, and the result will be placed on bus C. Okay, and then here the PC is going to read the address from using the bus C, and the address generator will generate that address of the instruction to be executed and place it on that particular bus C, and PC will read that value from bus C and it will be placed on bus B. So now the IR will read that uh, the contents from bus B. Fine. And similarly, this temporary registers also have the same way how this register file is get connected to bus A, bus B and bus C. In the same manner, this temporary registers component is also be connected. And this is the memory processor memory interface here. So it will be connected, it is reading from bus A, bus B and then bus C. It is writing to that bus C. So this interface is connected to cache and also the main memory. So let us consider the two operand instruction, how this instruction is going to be executed in the CISC style processor, because the CISC style processors may not use the same 5-stage uh, organization for execution of the instruction, fetching and decoding and execution of that instruction. So we have a sometimes some instructions requires more number of stages for execution, or steps are needed, more number of steps are needed for execution. Some instructions may require less number of steps. There is no hard and fast rule that each and every instruction in the CISC style processor will take 5 steps. Okay, so that is the reason this processor is said to be a complex instruction computing set processor, we are calling it as. So let us consider the two operand instruction here, add instruction taking the two operands R5 and R6. So here what we are doing here is that this will perform the operation that R5 contents and R6 contents are both are added, and it will be again stored into R5. So fetching and executing this instruction using CISC style processor can be performed in 3 steps. So now here, if you see this sequence of actions needed to fetch and execute this instruction, so we have only 3 steps for completing of this instruction execution in CISC style processors. So you see that in the step 5, so the contents of PC is loaded into the memory address, and the read memory control signal is issued by the processor, and then the processor will wait for MFC. Okay, then that signal that instruction which is available in the memory data register, that will be loaded into the IR. So this step which we are calling it as a fetch the instruction and increment the program counter. So now we are incrementing PC with value 4. Then next step is we have to decode the instruction here. So once you decode that instruction here, now we are performing in the third step arithmetic operation. So contents of R5 and R6 will be added, and again it will be stored into R5. So these are the three important uh, sequence of actions that are needed for execution of this instruction, two operand instruction in CISC style processor. Now let us consider another important category of the instruction, that is the logical instruction here, and operation. So and x of R7 comma R5. So which performs this logical and operation on the contents of the register R9 and the memory location, which is computed with an effective address as x plus contents of R7. So which is called it as x is an offset value. So and store the result back into the same memory location. Fine. So to execute this instruction, so it is necessary to access the memory 4 times. So why we require to access this memory 4 times? Now you can see that in the first, the opcode word is fetched. So then when the instruction decoding circuit recognizes the index addressing mode which is used here, so the index offset x is fetched again. Next, the memory operand is fetched and the AND operation is performed, and finally the result is stored back into the memory. So you see that here in the first step here, memory address contents of PC is loaded into the memory address, read memory control of a signal is generated and wait for MFC, and then memory data will be read into IR and PC is incremented. This step is same, and second step is decode the instruction. So once you decode that instruction, then now we are reading this program counter PC. We are reading into that and read memory and then wait for MFC, and the memory data we are placing into temp1, and then we are incrementing this PC equal to PC plus 4. Then contents of temp1 plus x R7. So here what we are using here is that to read this x value, which is nothing but an offset or displacement. So we are performing that by making use of this step 3. Then after performing the step 3, the data x value is available in the is placed into the temp1 register. Now we are calculating that x plus r7 contents. So now the x value is available in temp1 after the step 3. So now temp1 contents plus r7 contents are both are added and placed into the secondary temporary register. And then in the first fifth step, what we are doing here is that the contents of temp2 is loaded into the memory address, and again the read memory control signal is issued, and then wait for MFC, and then memory data will be loaded into the temp1. Then again here what we are doing here is that the contents of temp1 and the contents of R9 is logically performing the AND operation, and the result is temporarily stored in the temp1 register. So now the temp2 contents will be loaded into the main memory address, and the temp1 contents will be loaded into the memory data, and the write memory operation is issued, and once after read or write memory operation is issued, wait for MFC. So this is 7 steps are performed here by the CISC processor to execute this particular logical instruction and instruction. Fine. So that means here, as similar to this RISC style processor, there are no 5 steps that are strictly followed for execution of any of these particular instructions. Some instructions are executed of fewer than 5 steps itself. Some instructions are taking more than 5 steps in execution of these instructions in CISC style processors. Fine. So this is the today's lecture level practice problem. So now you try to solve this particular problem. So write the sequence of steps needed in execution of the following instruction using CISC style processor. So that is a load instruction, load R3 comma contents of R5 plus, this is what addressing we have used here. So auto increment addressing we have used here. Okay, auto increment addressing we have used here. Fine. So hope you got this particular point here. So try to solve this particular problem now. Okay, so thank you one and all.